Right, now let us learn how to draw the ray diagram. Okay, ray diagram, we have a ray diagram for reflections, mirrors, and we also have ray diagram for refraction or in lens. Okay, and then for each of reflection and refraction, we have also a concave surface, a convex surface. Okay, so we need to know how to draw. Okay, ray diagram, normally you have 3 rays to guide us to get the image. Okay, ray 1, ray 2, and 3. We only need to draw 2 out of these 3. Yeah, we just actually we just choose any 2 rays. Don't need to draw all 3. You just need to draw either 2 rays. Then we can get the intersection point. Okay, intersection point, and then that form the image. Okay, first of all, let's go through one by one each of these ray. Okay, so the first ray is very simple. Yeah, first ray is parallel. Actually, you know that to form the image is not just these 3 rays. There are many rays that forming the image, not just 3 rays. But these 3 rays are the most how to say, the key rays that can help us to find the image easily. All the other rays very hard, because only these 3 rays they are the key. Parallel, focal point, parallel, center curvature. So very easy to draw all these 3 rays. The other rays forming the image very hard to draw. Okay, only these 3 rays easily guide us. So we just choose any 2 of these 3 rays, we can easily draw the image. Okay, first of all, let us look at the first ray. Okay, I'm talking about the reflection mirrors. Okay, yeah, if you look at this mirror, this is a this is a concave mirror. Yeah, or I can say this is a concave mirror. Concave mirror is you see, focus a light. You see, you focus a light. So it is also called a converging. It is also called converging mirror. But for the other one, this shape, it doesn't focus a light. You see, it's reflect the light away. This one is called convex mirror. This is actually convex mirror. It also called a diverging mirror. Okay, it is also called a diverging mirror, because it diverges the light away. Okay, and then let us look at the first ray. The first ray is very easy. It's parallel. Yeah, it comes parallel, and then it will be focus to focal point or diverge from focal point. Parallel to focal point. You see, so this is the first ray. For concave mirror, comes parallel. Okay, comes parallel, and then go to the focal point. You see that? It comes parallel and then go to focal point. This is a converging mirror, so it focuses the light to the focal point. That's the first ray. The second ray is it goes towards the focal point and then focus parallelly. It goes to the, this is the second ray. You see, it goes to the focal point and then goes through the focal point and then focus parallelly. Back to parallel. Okay, parallel to focal point to parallel, and then the last ray is from center curvature, passing through the center curvature of the mirror and then go back undeflected. So this is coming center curvature and then reflected along the same path. You see, along the same path. So this is the third ray. Okay, so that's how you draw. Okay, you choose either of these 3 rays. Yeah, maybe you want to choose the first ray and the second ray, and then you can get the first image already. Get the image for the concave mirror. You see that this one. Okay, you see, this is the first ray. This is the first one, the red color one. First ray, parallel, go to focal point. See, passing through the focal point, and then the second ray is focal point, going to the focal point, diverge parallelly. Okay, and then the last one, ray 3, the blue one, passing through the center curvature and then reflected back along the same path, center curvature. You see, all these three rays, they meet at the same point. And they meet at the same point over here. See that? Meet at the same point over here. So we just need to find the intersection point. This intersection point is the place where the image is formed. Image is formed. That's why I just say just choose any two. You don't need to draw all three. Just need to choose either 1 or 2, 1 and 2, or 1 and 3, or 2 and 3. Then you can get the intersection point to find the image. Okay. Remember, for rays you need to have arrow. You don't just draw straight line like that. You don't just draw like see, don't just draw rays like this is the object. Don't just I normally use a straight line to. Don't just draw like that. The focal point is here. Don't just draw like that. The rays you must have arrow. Must have arrow. If you don't have arrow, then it's wrong. Okay. Then we have another rays. Another rays. Another rays, and goes like that. You must draw the arrow. So must draw the arrow. Then these two lines intersect at one point. They intersect at one point. This is the intersection point. So this is the image, intersection point. Image also, you must have arrow. You must have arrowhead. Like this one is mid. If the intersection point is below the axis, then it is inverted image. Don't draw like that. Don't draw like this. Mid below and it's still upright. Which is wrong. If the point is mid below, it is inverted image. Understand? And then image you must also label I. Must label I. Must label O as object. Must have the arrowhead. So it is inverted, or upright. Okay. So these are the things. Now, okay. And then for the convex mirror, one more thing. I want to talk about the ray diagram. Normally we don't. For this one, yes. This one he used the curved surface to reflect the light. But when you draw, you use a straight line to represent the mirror. Don't use the curved surface, because some people, your curved surface is really curved and doesn't follow the real sphere. Some of you, your curve is like this. How can it be possible like that? Then if your light reflect, your focal point is over here. Then how you reflect the light? If your light comes out, your light comes like that. Your light comes like that and then go to here, which is wrong. Okay, I want you to use a straight line to represent the mirror. And that means even though your mirror is very terrible looking, I want you to use a straight line to represent the mirror. First draw a straight line to represent the mirror. Okay, and then when you draw and then center focal length and center curvature must be equally spaced. Make sure you use your ruler. Make sure you use your ruler. Okay, make sure this is 2 cm. You measure properly. Okay, measure properly. Then draw the object. Draw the object. Okay, make sure this one, the focal length and between the mirror to the focal point and the focal point to the center curvature, they are equally spaced. And then you must draw a straight line to represent the mirror. So when you draw the ray diagram, make sure your ray just fall onto the not on the surface but on the straight line. Fall onto the straight line. Come parallelly. It will be focused to the focal point. Focus to the focal point. That's it. This is correct. Okay. I want you to touch the straight line instead of the mirror. Okay. because your mirror very terrible looking. I want you to touch the light. I want you to touch on the straight line and then reflect it away. Okay, understand? So same thing, yeah, same thing like this one. Don't follow this one, because your sphere is not as perfect as them. I want you to all draw the straight line to represent. That means like this one, I'm going to draw a straight line, straight line, represent. That means your ray, please drag to the straight line and then reflected. Then only reflected. This one also, towards a straight line. Okay, this one also towards the straight line here and reflected away lah. Okay, towards a straight. This one also, like this one also, draw a straight line to represent. Hold on a second. I want you to draw a straight line to represent the mirror. Straight line. So when reflected, draw like that. Okay, just touching the straight line, and then you can reflect away from the focal point. This one, I want you to draw like that. Understand? Use the straight line as the guide. Use the straight line as the guide. Okay. Now, okay, back to here. Okay, so that's how you get the image for concave mirror. And then diverging mirror. Diverging mirror, you see, diverging mirror, the focal point is at the other side. Focal point is at the other side. The center curvature also. Similarly, you look. I want you to draw like that lah. Okay. See, the first ray is parallel to focal point. Yeah, parallel to focal point. So first ray is parallel first, and then diverge from the focal point. Diverge from the focal point. It's not converging, it's diverging. Parallel, diverge from focal point. And then the next one is towards the focal point, back to parallel. Yeah, it's towards the focal point and then diverge parallelly. Yeah, it start from towards a focal point, then diverge parallelly. Okay, and then the last one is also center curvature, towards the center curvature, back on the same path. Towards the center curvature and back to center curvature. Center curvature. Okay, you see, this is the dotted line. You need to draw dotted line. What does it mean by this dotted line? If you look at carefully over here, this is the first ray just now. Parallel, diverge from focal point. I don't like you curve diverge from the sphere, from the mirror. Better you use the straight line, and then you get accurate image drawing. Always use the straight line. Use this. Okay, all the light. Better you diverge from the straight line. Then now look carefully. The first ray, it diverges from the focal point. Okay, and then diverge from the focal point, and then for the second ray, it goes towards the focal point, diverge parallelly, and then third ray is towards the center curvature, back to the same path. So what does it mean by this dotted line? What does it mean by this dotted line? If that means when my eyes is over here, when my eyes is looking at the mirror, what I see is this light, the first ray. You know, the first ray, which is this one. This is the first ray. It comes from a straight line. I come from a straight line. I see from my eyes is over here. I'm watching, and then for the second ray, what I see is this ray. It comes from straight line behind here. Understand or not? And then I see the third ray. The third ray also reflect back, isn't it? Reflect back. I see the third ray coming from a straight line like that. That means what I see is I see the first ray coming from a straight line like that. Yeah. Again. should use the first ray. The first ray. Let me see. The first ray. I see this first ray coming from a straight line like that. Understand or not? And then the second ray, I see it comes from a straight line like that. And then the third ray, I see comes from a straight line also, a straight line. Like that. Understand or not? Well, I see this light come from here. I see the third ray come from straight line. I also see the second ray come from a straight line horizontal. That's why I thought these three rays, the blue, the red, the green, all come from this image position. So I thought I see something here. This is actually the virtual image. I see the image over here. Okay, it all come from this point. Understand? Now, yeah, that's the way lah. Okay, diverge parallelly. Yeah, parallel focal point and go focal point parallel. So what I mean is what I see is again that's over here. The first ray, it diverges from focal point. That means I see the light. I see this is the light. This is standard. And then the second ray, I see my eyes is over here. My eyes is over here. Understand? My eyes is over here. My eyes is over here. So what I see the light come from here, and then I also see the light. This light, this second ray, I thought is come from here. Understand that? I thought come from here, and then the third ray, I thought is come from here towards the center curvature. That's it. Yeah. I thought it come from here. Okay. So these are the three rays. Okay, these three rays form the image lah. Form the image. All right. So now, that's about the mirror. Now, how about actually behind here there's no light. Here behind there's no light. Behind there is no light. But no light actually coming from behind there. No light coming from behind. But it seems that this light all originate from that position. Yeah. It seems that this red light originate from that position. This red light actually doesn't come from the focal point. This red light actually comes from the object here, coming from the front of the mirror. But my eyes assume that this light comes from behind the mirror. Same thing goes to this green light. This green light, I thought the green light comes from a straight line, but actually the green light doesn't come from behind the mirror. The green light actually comes from the object also. It's just that the mirror reflect the light, go back in the opposite direction. That's why I thought that this light actually comes from behind the mirror, but actually it's not. It's actually come from the object being reflected away. Same thing, this one, this blue light also, I thought this blue light comes from here, but actually it's not. This blue light actually comes from the object, object, and then being reflected away along the same path. Okay. Now, how about the thin lens? Thin lens, also same. You see, I use the same method, the ray one parallel to focal point, and then focal point to parallel, center curvature to center curvature. So you see, this one also the same, ray one parallel focal point, and then focal point parallel, and then optical center, optical center. I just change this from C to O. Okay, look, for the first ray, this is the first one is called what we call, this is a convex. This is a convex lens. A convex lens is converging. Last time is concave mirror. Concave mirror is converging. This time is convex lens is converging. Okay, just the difference of this one lah. And then this is a concave. This is a concave lens. This is a concave lens. So this is diverging. This is diverging. It diverges a light. You know what's mean by converging and diverging? Converging means it can focus the light. Yeah, this one means can focus light. Yeah, This one diverging means it spread out the light. It spread away the light. Spread the light. It doesn't focus the light. It spread the light. Same thing like this one. This fat guy. This fat guy, convex lens, converging. It focus the light also. It focus the light. Yeah. And then this one, the thin guy, it diverge the light. It spread out the light. It spread the light. Understand? Okay. But this one for mirror, if the light is reflection, that means the mirror is focused at front of the mirror. The light is focused at the front of the mirror because of reflection. The light cannot pass through. It's focused in front of the mirror. But for the lens, it is focused at the other side of the lens, not at the same side. Because the light can pass through of refraction. You know, refraction, the light can pass through. The light is focused at the other side. This one is focused at the same side. This one focused at the other side. Then, but for this one, for the diverging, this one is the light is spread from the other side. And this one, the light is spread from the same side. That's the difference. Understand? Okay, now let's look at the first ray. The first ray is first is parallel. First is also the same. You see, for lens also I also use a straight line to represent all the light. All diverge and converge from the lens. Okay. All converge and diverge from it. What I can say is what I can say for mirror, okay, for mirror, this is the mirror, okay, this is a concave. What if a convex? Convex also I use a straight line to represent. I must use a straight line to represent the mirror. So all the light must diverge from this straight line. That means my, okay, this one is my focal point over here, and this is center curvature. So my light must reflect from here, not from the surface. Diverge from the focal point. Diverge from the focal point over here. All begin from here. Understand? This one is correct. Don't you go to draw like that. Don't you go to draw like that. What I show over here, like here, because your curve is not good. Your curve is not good. If you diverge from the surface, afraid you can't get the nice image. Afraid you can't get a nice image. If you diverge from the surface, don't. Yeah, you must use this one. Must use the the light. Please don't diverge at the surface. Please use the straight line to represent. Please use the straight line. This is correct. You need to do like that. Don't diverge from here. Although of course it diverge from here, but because the curve you draw is not beautiful. So all diverge from the straight line. All converge and diverge from the straight line for mirror. For lens also the same. You see, if like convex lens, if let's say I have a convex lens, I also use straight line to represent. Okay, straight line represent. So if let's say I have the focal length, this one have, and then you must be equally spaced. That means better you make use ruler, measure 2 cm, 2 cm, or 3 cm, 3 cm. Measure, and then if let's say your object is over here. Okay, so yeah, so the light comes parallelly, converge at here at the straight line. Use the straight line. Use this straight line, okay, to converge. Converge to the focal point. Yeah, understand? Use the straight line. For the what? For the concave. Concave also use a straight line. Use a straight line to represent. The straight line at the middle. Yeah, straight line at the middle. So the light also, okay, draw all this all this. So the light comes come light and then diverge from the focal point. Diverge. Use the straight line. Understand? First, you must draw the straight line. Understand? Okay. Finish. All must use a straight line. No matter it's mirror or lens, use a straight line to represent where the light converge or diverge. Okay. Always use a straight line in the mirror. Now, go back to our this one. Okay. So the first ray parallel to focal point. So for the first ray parallel to focal point, you see that comes parallelly and then converge to the focal point. That's it. Yeah, converge to focal point. It converge at the other side. And then for this one is ray. This one is ray 1. This one is ray 3. Actually, this one is ray 2. Yeah. So for ray 3, okay, it comes with going optical center, passing through the optical center. This at the center here is O, optical center, passing through the optical center, undeflected. Undeflected, just passing through without any deflection. That's ray 3. And then for ray 2, okay, for ray 2, ray 2 is passing through the focal point, then go to parallel. Passing through the focal point and then back to parallel. See? Same thing like before. Okay, same thing like before. Okay, parallel, focal, focal, parallel, center curvature, center curvature. This one also parallel, focal, focal, parallel, and then optical center. Okay. It's just that this one it focus at the focal point on the other side, but this one focus on the focal point at the same side for mirror. Okay, that's 3 rays. Then if we have 3 rays already, we choose either 2. Then we can find the intersection point, and that's our image. That's our image. Draw. Okay, label with I. Just choose any 2 also. Yeah, choose. Choose any 2. Okay. Now for the concave lens, this one is a real image lah. This one is a real image because all the light fall onto it. Yeah, all the light fall onto it. It's a real image. That means if we put let's say if we put a paper over here, you can see the light fall onto the paper, so it form a real. But for this one, okay. So first ray is parallel to focal point. Yeah, same thing. This one is parallel but diverge from focal point. Diverge from this focal point. This is the first ray. And then the second ray, focal point to parallel. That means going to the focal point. Going to the focal point on the other side, but diverge parallelly. Okay. So and then for the last one, ray 3, pass through optical center, undeflected. Pass through the optical center, undeflected. This one actually passing also undeflected lah. This is number 3. This is for number 2. Now. Okay, so what I can say is what I can say for this one is if what I can see from this light actually the first ray, I thought this ray come from the straight line. You understand? Because my eyes only assume the light come from a straight line. So I thought that this ray, what I see is coming from straight line here. Understand or not? And then for this one also, the light enter my eyes. I thought that this light actually come from a straight line. I come from here. And then for the second ray, my eyes is over here. Okay, what I see is the light. I thought that the light come from this side. Yeah, it come from this light. I thought it come from here. Yeah, I thought it come from here. Straight line. Is that or not? That's why you draw a dotted line behind. So conclusion. What I can say over here. See, this is the concave lens. Just now I'm talking about concave lens. Look at this one. What I see, I see this real virtual image through the lens. That means if my eyes is over here, I thought that this first light come from a straight line, like that. Understand or not? And then I also thought that the second ray, the green light, come from a straight line. Yeah, I thought that this light come from here. Understand or not? And then I thought the third ray also come from a straight line. I thought that a ray come from a straight line. Third ray come from a straight line. Is it correct? So you can see these three rays. The first ray, the third ray, and the second ray, they all come from this point. You see not? It comes from this point, this position. It comes from this, the section point here. Yeah, it comes from here. So image is formed here. I saw an image here. I only see this image through the lens. This image is a virtual image because it cannot form on screen. I only see this image through the lens. Okay, so that's all for lens and mirror. Okay, like this one also. You see, my eyes are looking inside through the mirror. These three rays, I thought it come from here. This is a virtual image. And then this one also, I thought these three rays come from this point. Right? That's all for. So very simple. You just need to remember this one. Parallel to focal point to parallel, center curvature, mirrors. Lens also the same. Parallel focal point, parallel, optical center. Alright, see you in the next videos. Bye.